Section 3.5, solving nonlinear systems. Very similar to solving linear systems, but we do introduce one vocabulary term here today. Nonlinear system. So if something is nonlinear, it means it's not a line. So a nonlinear system is a system of equations where at least one of the numbers, one of the equations is not linear. It's kind of a basic definition, kind of makes sense right away off the bat. Okay, we're going to look at two different ways to solve these systems. The first way is the substitution method, and the steps are really no different than when we were doing 3-variable systems or doing 2-variable systems in Algebra 1. Step number 1, solve one equation for one of its variables. Step number 2, substitute into the other equation and solve. And step number 3, substitute and solve for the remaining variable. Now, substitution method probably is going to work best when you have, one of the equations is a line. So it's something like number 1 here, a quadratic, and then a linear equation. So one quadratic, one parabola, and then one line. Okay, so solve by substitution. Number 1, ideally, and like I said, I didn't talk about this, but for step number 1, we prefer to solve the linear equation for y. Okay, so what we're going to do here is get y by itself in this second equation. Okay, so what we're going to do, we're going to move this x to the other side. Okay, so it's going to be y equals, we can either write it as 4 minus x, or we could write it as negative x plus 4. Okay, so there's step number 1, solve one equation for one of its variables. We did that. We have y by itself in the second equation. Step number 2 then says substitute into the other equation and solve. Again, this is just like 3-variable systems. So we know what in the second equation, we know what y is equal to, so now we're going to replace y with negative x plus 4. Okay, so let me slide this down. So we'll have x squared, that doesn't change, neither does the x, minus, now there's y, so we know y is equal to negative x plus 4, and that is equal to negative 1. Okay, so this is like a negative 1. We can distribute that, so we'll get x squared plus x, and then negative 1 times negative x is positive x, and negative 1 times 4 is negative 4, and that's equal to negative 1. Okay, in order for us to be able to solve this, we need it to be equal to 0, and we need to combine some like terms. Okay, so let's combine those. Let's move the 1 over to the other side. So we'll have x squared plus 2x minus 3 is equal to 0. Now, we have a couple of different options. We could graph it, we could factor it, we could use the quadratic formula. To me, factoring makes the most sense. So now we're kind of into, well, we're still finishing up step number 2. Now we're going to start solving. Okay, so x squared plus 2x minus 3. We need to figure out two numbers that multiply together to get negative 3 and add together to get positive 2. Those two numbers, and since the number in front of x squared is 1, we can go right to the parentheses. Those two numbers are positive 3 and negative 1. Okay, because negative 3 plus 1 is 2, and negative 3 times negative 1 is negative 3. Okay, so now we're factored. Now we can finish solving. Okay, so we can set each factor equal to 0. X minus 1 equals 0. These are just one-step equations. We have x equals negative 3, and we have x equals positive 1. Okay, well, but we're not done. Okay, that's the end of step 2. Substitute into the other equation and solve. Step number 3 then says substitute and solve for the remaining variable. Now, I'm going to keep this y equals negative x plus 4 in the back of my mind, because these are both x values that I'm going to plug in right there. Okay, and I need to find my y values. Okay, so we'll have y equals negative and then x plus 4. So negative, the opposite of negative 3 is 3 plus 4, that would be 7. Do the same thing with your x value of 1. Y equals negative 1 plus 4. Obviously that's negative 1 plus 4, and that is 3. Okay, so what this tells me, let me switch to a different color here. We'll switch to orange. So I have an x value of negative 3 and a y value of 7. What that tells me is that negative 3, 7 is on the graph, and then I get an x value of 1 and a y value of 3, which tells me that 1, 3 is on the graph. So really, thinking big picture here, let me switch colors one more time. Let's go to yellow. If I was going to look at a graph of this system, this one way back here at the beginning, this one, what this really looks like, so they intersect at negative 3, 7, which might be somewhere up in here, and they also intersect at 1, 3, which might be somewhere in there. I know one of them is a line, and then the other one is a parabola. Your graph might look something like that. I'm not sure, I'm just estimating here, but this is kind of what we're looking at. We're looking for these 2 points of intersection, or any points of intersection. Sometimes you might get 2 points, sometimes you might get 1, sometimes you might get none at all. And we'll look at a case of that a little later. All right, let's move on. Number 2, x squared plus 2x minus y is equal to 5. 2x plus y is equal to 7. Again, step number 1, get one variable by itself. Solve one equation for one variable. I'm solving the second equation for y again. Again, if there's a linear one, I would definitely suggest solving that one for y. So y is equal to, you need to move the 2x to the other side, so I'm going to have negative 2x, and then I have positive 7. There's step 1. Solve one equation for one variable. Step number 2, plug it into the other one. Okay, so we're going to have x squared plus 2x minus my y value. I know y is negative 2x plus 7, and that is equal to 5. Okay, again, you could distribute a negative 1. X squared plus 2x, negative 1 times negative 2x is positive 2x. Negative 1 times 7 is negative 7, and that's equal to 5. Again, get everything to one side, so we're going to subtract 5, going to subtract 5, combine those like terms, we'll have x squared plus 4x, negative 7 minus 5 is negative 12, and that's equal to 0. Again, if you can factor it, I would suggest factoring. It's going to make things very easy or very simple. If you want to use the quadratic formula, you could use the quadratic formula. You would get the same answers. It might just take you a little longer. Number in front of x squared is 1, so we can go right to the parentheses. You need to find two numbers that multiply together to get negative 12, add together to get 4. Those two numbers in this case, positive 6 and negative 2, and those two numbers go inside the parentheses. Once we've got it factored, then we can solve. Again, these are both single-step equations. I'm going to skip some of the work. I'm going to know that x is equal to negative 6, and then x is also equal to positive 2. Now, again, I'm going to rewrite my equation. I had y equals, what do we have, negative 2x plus 7. Okay, because that's going to help me find my y, because I need to find my y values. There are y's in my equation. Okay, so there was step 2. Solve this one equation for, let me go back. Step number 1, solve one equation for one of its variables. Step number 2, substitute in and solve. So there's the answer to step number 2. Step number 3 then, take these two numbers and put them back in your equation to find the second variable. Okay, so we're going to have y equals negative 2 times my x value, which is negative 6, plus 7. Negative 2 times negative 6 is 12, plus 7, that is 19. Do the same thing for the x value of 2. Y equals negative 2 times my x value of 2 plus 7. Negative 2 times 2 is negative 4 plus 7. That would be positive 3. So again, what does this tell me? Well, it tells me that when my x value is negative 6, my y value is 19. And when my x value is 2, my y value is 3. These are the 2 points of intersection of my graph. Do you need to sketch it every time? No, I was just showing you in the last example what we're kind of looking at, but these are the 2 solutions to this system. All right, let's move on to the elimination method. The elimination method I would recommend probably more for when you have 2 quadratics or neither equation is a linear equation. Okay, so the elimination method, number 1, add or subtract the 2 equations to eliminate one variable. Hopefully we don't have to do any multiplying, but I guess that would be step 1. If we need to get one of the variables to have the same number in front, then that's how we would do it. We would do step 1 first, where we multiply everything by a number. Step number 1 officially then would be add or subtract the 2 equations. We're looking at the variable that has the same number in front, so in number 1 down here it's going to be the y's. Remember, if we have the same sign, we subtract. If we have different signs, we add. Step number 2 then, solve for the remaining variable, and step 3, substitute and solve for the second. Okay, so number 1, solve by elimination. We don't need to do any multiplying because our y values have the same number in front. Granted, they are opposite signs. So what that tells me, if we have opposite signs or different signs, we need to add the 2 equations together. So add straight down. 2x squared plus x squared gives me 3x squared. Negative 5x plus 2x is negative 3x. Negative y plus y is 0. Those cancel out, or they are eliminated. And then negative 2 plus 0 is negative 2. So there's step number 1. Solve or add or subtract the two equations to eliminate one variable. Step number 2, solve for the remaining variable. Obviously, the remaining variable is x here, and in order for us to solve for x, we need this to be equal to 0. Okay, so we'll just move the 2 over, so we'll have 3x squared minus 3x plus 2 is equal to 0. Now, the number in front of x squared is not 1, and I don't really want to try factoring this, so let's go ahead and use the quadratic formula. Again, remember the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Okay, here's a, here's b, here's c. Let's plug everything in. So we got x equals negative b, so b is negative 3, so we're going to have positive 3 plus or minus the square root of b squared, so negative 3 squared, minus 4 times my a value, which is 3, times my c value, which is 2. That whole thing gets divided by 2 times my a value, again being 3. Okay, so let's clean some of this up. So we get 3 plus or minus the square root of negative 3 squared is 9. Negative 4 times 3 times 2. 4 times 3 is 12, times 2 is 24. So this is 24. We got one negative in that multiplying, so it's going to be minus. And then 2 times 3 is 6. Keep going a little farther. We get 3 plus or minus the square root of, let's see, 9 minus 24 is negative 15. All of that gets divided by 6. And I would say we are done right here. The reason we are done is because when if we try to clean this up any farther, we're going to get imaginary answers. Okay, we have a negative under the square root, which leads us to imaginaries. This one right here, if you get to this point, you can stop, and your answer is no solution. Okay, there's no solution, there's no real solution to this quadratic inequality, or not inequality, equation. Okay, there's no solution, no real solution here. So if we were going to look at a graph, for example, let me switch colors here, let me go to orange. What this graph looks like is something like this. We're looking for the point of intersection of these two parabolas. And if you were to graph those two equations, the original two back at the beginning, you would get something that looks like this. And if they don't intersect, then there's no solution. Okay, so if you get to this point where you have a negative under the square root, you can stop, because there's no way you're going to get a real answer, which means there's no solution. Okay, let's try another one here. Number 2, 2x squared plus 4x minus y is equal to negative 2. X squared plus y is equal to positive 2. We do not need to do any multiplying because the y values are already the same again, and that's a good thing. We usually want to get rid of y because we can do things with x and x squared. Y is kind of just getting in the way. Notice in the second equation there's no x value. There's just x squared and y. So what I'm going to do, I'm going to rewrite the two equations, 2x squared plus 4x minus y equals negative 2. And then I'm going to rewrite the second equation with a space in it. So plus y is equal to 2. That way we just understand that there's no x's here. Okay, so when we do our adding or subtracting, and in this case, again, we have different signs, one negative, one positive, that means we are going to, whoops, go back to the pen, we are going to add the two equations together. Okay, so add straight down. 2x squared plus 1x squared is 3x squared. 4x plus 0x is still 4x. Negative y plus y is 0. And negative 2 plus 2 is also 0. Okay, so this is already equal to 0. So let's see if we can't work this down a little farther. Step 1 is done. Add or subtract the two equations. Step number 2, we need to solve the resulting equation. Now, this one, 3x squared, 4x, both of them are divisible by something. They are both divisible by x. Okay, so let's try to undo the distributive property here and see if we can't get something nice. Okay, so 3x squared divided by x, or think about it this way. X times what would give me 3x squared? And the answer to that is 3x. Again, do it again. X times what would be 4x? And the answer there is positive 4, and that's equal to 0. Now, this is a part of the product. This is a factor. This is also a factor. This is already factored. We do not need to do any extra work, okay, because this is kind of like x plus 0 times 3x plus 4. Okay, we don't need to do any extra work to get this factored. Okay, so what this tells me is that, well, the only way to make this 0 is if x was equal to 0. And then for the other one, 3x plus 4 needs to be equal to 0. Okay, this one is already done. This is the second one right here. This one is a two-step equation. Okay, so we're going to have 3x is equal to negative 4, and then x is equal to negative 4 over 3. Okay, so we have our x values, 0 and negative 4/3. Now we need to go find the y values, because remember, our equation had y's in them. So we have a couple of different options here. I'm going to use the second equation. The second equation was, let me go back to it, x squared plus y equals 2. I'm going to write that off to the side. X squared plus y is equal to 2. I think this one's going to be a little easier to use just because there's only one x value. Okay, for the first one, so we'll have 0 squared plus y is equal to 2. Well, that makes it easy. 0 squared is 0, so that tells me y is equal to 2. So there's the first ordered pair, 0, 2. Second equation, or the second solution, we need to plug that in as well. So we got negative 4/3 squared plus y is equal to 2. Negative 4/3 squared means negative 4/3 times negative 4/3. Negative times negative is a positive. 4/3 times 4/3 would be 16/9 plus y is equal to, now I'm also going to turn 2 into ninths. That would be 18/9. 18 over 9 is 2. I haven't changed the value, just changing its appearance. And then it's a single step equation from there. Just need to subtract 16 over 9, subtract 16 over 9. 18 over 9 minus 16 over 9 is 2 over 9. That would be our second y value. So let's summarize here. So our one ordered pair was 0, 2. That's what the first part told us. Second ordered pair, negative 4/3, comma 2/9. That would be our second ordered pair.